go through the notes that contains so many topics with an elaborative nature. So if you're free, just go through it. Okay. Is my screen visible, Charan? Okay. Thank you. Connect ஆகிறதுக்காக கேட்டேன் ஒன்றும் இல்லை. Thank you. சரி. Okay, we'll see the interfacing circuits. You know very well, obviously, whenever we have transducers, generally the transducer may consist of sensor along with the interface circuit to provide the conversion, right? So that is what transducer is initially. That and all we have seen. So now we are just going to concentrate only on the interfacing circuits. How could we interface the sensor with the loads? A load in sense final output detection. Respectively, if you are going to detect any outputs, so or going to detect any temperature variations or resistance variations, or likewise whatever the parameter you are going to detect, that respective thing will be connected with the sensor unit by making use of this interface, right? So here we'll see interface circuit is nothing but what? A signal conditioning. Yes, obviously. Why? It has to balance the signals, right? So balance the signals which emerge from the physical conditions, the physical realization. Here the load device will consist of the information which may be in a real-time environment. So obviously it consists of a physical nature of information, right? So real-time information will be here. So that is what your physical information. So this respective signal has to be correlated with the sensor producing signals. So the sensor signal producing signals will be in the nature of digital, right? So here the interface is a circuit which is going to balance both the digital information along with the real-time information, right? So this is what it's going to do. So in order to bring the signal from the sensor up to the format, so right, so up to the format is nothing but what? In order to either convert that into some real-time information, or by correlating the digital signal with the real-time information, that will be done by this interface circuits, right? So this is what it's going to do. Here we will be providing any stimulus from the physical environment. The sensor will realize the information. Once that realization will be in terms of digital, that has to be balanced in order to observe by the physical people who is in real-time environment, right? So that may be in terms of alert or maybe a digital display, so whatever, right? So that has to be correlated and converted, right? So this is what interfacing circuit is. Within this interface circuit, so how this interface circuit could be built up? By considering the parameters called input impedance, output impedance, offset, that and all, right? So that and all previously we had seen. So these are the required parameters, major parameters. Your whatever the interfacing you are going to build up. So everything has to be for everything you need to concentrate on these parameters, right? So input impedance. Let's go by one. Let's go one by one. So initially we'll look into this input impedance. You know what's input and all. Then what's impedance? This I had told you in the first unit itself. Impedance is nothing but this could be measured. Resistance is similar to impedance, but not exactly. Why? Since the resistance value could be calculated in DC parameters, DC voltage, DC supplies, whereas the impedance could be calculated in reactive reactive sense, right? So that obviously go for the case of AC. Right, so for the signals which is in nature of AC, we would mention that respective term as impedance. If it's DC, we would represent that term as resistance. Right, so this is what exactly the equation is similar to that of resistance only, but here we have some reactance value, right? So it depends upon the reactance nature, so the phase variations will be there, right? So for that thing, the variation in voltage and current will also be there. So that's what impedance, we are mentioning it as impedance, not resistance, since we are going to calculate the value in AC, which is in AC, right? So this is what it is. So impedance, input impedance. So at the input side, what would be the impedance? You need to identify this one, right? So in sensor being connected to the interface circuit, so obviously this respective location we would mention as input, right? So if you calculate the value here, if after beyond this location, after this interfacing circuit will provide some output that will get connected to this load value, right? So the load thing, so the region beyond the interface circuit will go for the output, but from the sensor to the interface circuit will act as an input, right? So you need to identify the input impedance. So impedance, you know what would be the parameters which is being involved to calculate the impedance, that is voltage as well the current, right? So for the interfacing circuit, you need to identify what would be the voltage as well the current. So for that case, you know very well, if there is a voltage or current, obviously that there the resistance value has to be there, right? So according to Ohm's law, you know very well, if there is any inducement of voltage or current, obviously there will be the resistance. Then if we have the value of current, there will be the what, either dissipate, since it's an AC nature, you know very well, since we are calculating the AC current or AC alternating current or alternating voltages value only we are going to calculate. So if that's in the nature, so obviously whatever the voltage or current, there will be in the dissipative as well the increasing nature of curve, right? So there will be the storage of the energy. So you know very well, for storing the energy, we will use capacitor, right? We use capacitor to store the energy. Also, it will provide you, or it will show you the value in terms of dissipation as well the increasing nature of curve, right? So there at some point there will be the increased in nature as well at beyond that specific limit, it will start to dissipate the energy which is being stored, right? So this is what will happen within this capacitor. So this is what the interface why, if you are going to calculate the voltage or current, obviously there will be the resistance value. So whatever the energy we have, that has to be either stored or dissipated, right? So the storing and dissipation process will also be carried out by the use of the capacitor, right? So this is what we have. That clear? Shall I rub all this? Okay then. Now, if we have an input circuit, likewise as here, as connected here, so if we have a parallel connection of input as well the capacitance value we have, right? So if you want to calculate the impedance value, how would we calculate? You might have studied in circuit theory and all circuit analysis, right? So in that thing, you could calculate the value as Z equal to R divided by 1 plus j omega RC. This is what the impedance value is, right? So the impedance value could be calculated by making use of this formula. This is not that much quite complicated formula. It's a simple one only. So if you just substitute the value of V as well I, then obviously you would receive this formula. So you know very well, V equal to what? I into R, right? So I into R, this could be written as I into R. Also, you may write this entire expression, I value. I also could be written as what? V by R, right? So if you have written like this, it as V by R, instead of the value of V, that is the supply voltage value, you could substitute the values like 1 plus j omega RC. Since we have R and C in a parallel combination, that could be written as 1 plus j omega RC. J omega represents the reactive nature of the whatever the parameters we are using here, right? So j omega, omega itself represents the reactive nature. This j represents the complex nature of the thing, right? So complex nature, when you calculate both positive and negative halves, obviously we will calculate the complex nature of the information, right? So that and all you know very well. So once you have written the expression like this, obviously if you if you make the alterations in this expression, that will come as r divided by 1 plus j omega rc. This and all you might have studied. So then if we are using any low frequencies, that is we will be providing the supply, that is voltage supply to this circuit, right? So for that thing, if the supply voltage or supply voltage consists of 50 hertz, you know very well, right? So the frequency we will be providing for the supply would be of around 50 hertz. If you are reducing the voltage to a lower extent, if you are reducing the frequency to a lower extent, what's frequency? Number of cycles per second. This and all I have taught you, right? So number of cycles per second. So if you are reducing this frequency to a lower extent, what would happen? Purely here we have omega. Omega is nothing but 2 pi fc. 2 pi f along into c. This f represents frequency, right? So this f represents frequency and c represents the capacitance value. So this, sorry, not c, 2 pi f, omega, which is equal to 2 pi f. This f represents frequency. So the frequency value is, if we are considering the frequency value is approximately equal to 0, let's consider. If it's 0, then what would be the value if I substitute at this location? 2 pi f, 1 plus 0. 1 plus 0 will also result in 1 only, na? Here, if I substitute the value. So if I am going to consider this as the equation, so r divided by 1 plus j, instead of omega, I am going to represent this as 2 pi f, right? So 2 pi f into rc I have. So then for substituting the, I'm just going to consider at very low frequencies. The frequency value is of about very low level. Then I'm making the consideration f value is 0, approximately equal to 0. Then what would be the value I would receive out of this? I would just substitute the value of 0 in this term. Then that will just provide you the value of r divided by 1 plus 0 exactly. Right? So r divided by 1 plus 0. That will result in what? R only, na? R by 1. Again, R by 1 is nothing but R only. So, which will approximately equal to the value of R at very low frequencies. This is what the condition is, right? So, also we could calculate the value for a high value too, but we are only bothering about the low frequency value. We are for measuring any sensor values for the sensor and all, we are in the requirement of very low voltage level. So for that case, obviously the frequency value will also be in a very low level. So for that thing, we are not going for the consideration of very much high frequency level, right? So that and all the case. So this is what this is how we should calculate the input impedance value. Then the next interface parameter is what? Output impedance, right? So here output impedance. So once at the input side, from the sensor to the interface circuit, we have calculated the input as well. For the output impedance, we are going to calculate what? The output value across the load as well from the interface circuit. This is what we are going to do, right? So for that thing, voltage source sensor. So example, the voltage source sensor will provide you the value of output impedance very well. So here we will see the circuit. Yes, here it consists of sensor. Yes, you know very well, sensor. The output impedance value, from that only we are going to calculate as well. We know the value of input impedance too, right? So circuit input impedance too we know. This and all we have. Then the output value, the output signal we are going to calculate. That value may be represented as what? Voltage source value, right? So voltage value, and that's been connected in series with output impedance. There we had seen the resistance as well the capacitance being connected in parallel, right? So parallel location, it is being connected look into obviously the resistance, the impedance value being conducted in a series manner over the entire circuit, right? So this is what you need to think carefully. So then for measuring the voltage source sensors, that has to be connected in a serial nature. Whereas for the measure, if you are going to measure the current value, if you're going to measure this voltage value, then obviously whatever the load parameter we have, that has to be connected in serial nature, series and parallel and all, you know very well, I think, right? So if both of if any one of the nodes shares each other, then that's in series condition. If both of your nodes share each other, then obviously parallel connection exists there. So that and all, you know very well. So now for the case of current source, so if you want to measure the value of current by providing the current as a source, then obviously it has to be connected parallelly with the output impedance value. These are the two things you have to do while measuring the while constructing the interface circuit, as well while measuring the information. These are the two things you need to identify, whether you are going to observe the information for the source as voltage or for the source as current. If for the source as voltage, then obviously what you are going to observe, that has to be connected in series nature. Then for the measuring current, that has to be connected in parallel. This is what you need to careful with. Then the measuring of the input impedance, input voltage value would be like this, right? So Z input impedance in the input side to the input impedance plus output impedance, right? So the reciprocal, the ratio of both the input impedance to the overall combination of the impedance value, which has been present over the entire circuit, not only at specific location, but at the overall impedance value, right? So this is what the output calculation of output impedance for the source, different sources, voltage as well, the current sources, right? So why? Yes, Sanjana.
Ma'am, your screen is not visible.
How long?
I think before 5 minutes, ma'am. Now only, ma'am.
Okay. One second. Is it visible now?
Yes, ma'am.
Sanjana?
Yes, ma'am. Now visible, ma'am.
Is it visible now, Sanjana?
Yes, ma'am.
Okay, then thank you. Okay, this is what the input impedance. So, okay, you might have left this portion. So I'll just recollect again. So nothing but the same thing as you have seen in the input impedance. Here, same condition, output impedance case. Here, whether you are going to consider voltage as an input source or the current as an input. If that's the case, for the case of voltage as an input, then you need to connect whatever the voltage source that has to be connected serially with the output. Whereas for the case of current, if you are providing the input value as a current, then obviously whatever the source you are going to calculate, that has to be connected in parallel with the output impedance. This is what you are going to do. So out of that thing, you could calculate the value, right? The input voltage value likewise. So here it's nothing but, since we are calculating the input value, we need to consider only the input impedance value, right, for the total values. If you are going to calculate the output voltage value, then obviously this value would be your output impedance to the total value. Here this is nothing but Zin plus Zout represents what? Total impedance value. So that's nothing but total value, total output impedance value you may have, right? So this is what this is how we could calculate the output impedance value. Then what's the importance of calculating the input impedance? That's a quite important parameter. Why we need to calculate the input impedance value? Yes, we are going to calculate, while we are going to design the interface circuit, you need to concentrate on the parameters like input impedance, output impedance, offset voltage. So the likewise most of the parameters are there. So but the input impedance is very much important. Why? So let's see why it is. So if you want to measure the input impedance, we are going to consider some purely resistive sensor. So resistive sensor, what's the term called resistive sensor? Yes, any guesses? Purely resistive. So whatever the purely resistive, the term resistive represents what? Whatever the input value you are providing, that will be 10% resisted, right? 10% it will be avoided, or it will be counteracted. So this is what the resistance nature, right? So sensor value will be what? Whatever the information you will be providing, that will be resisted if that's been connected to the input impedance value. So how the voltage value could be calculated? So the voltage value is nothing but it will represent as a function of frequency. Yes, you know very well. So since we are considering the AC voltage, obviously that would be the representation of what? Frequency only. That and all you know. So that's why we are representing the impedance value as 2 pi f omega j omega RC j omega RL likewise. Since we are considering the capacitor within the interface circuit, I'm just representing it with C. If I have considered the inductor value, then obviously I would represent this with R into L. But here that's not the case. Here we are considering only R into C only. So for this representation, so you know very well this omega is nothing but 2 pi f, right? So 2 pi f, so that's what the frequency is. So by considering this frequency value, your information, that is input value, may differ, right? So for the case of calculating the frequency with the capacitance, right? So you know very well, here we have the capacitor. Yes, for this capacitor, we will be providing the AC supply. Yes, again, we are providing the AC supply. Once there is a AC supply, there the calculation of frequency comes into effect. Yes, that is what 2 pi f will come into a role. So if there is a 2 pi f, for the case of C, the reactance of this capacitor you need to calculate, right? So for each and everything, we are going to calculate the reactance value. So for the case of as it's similar to that of resistance only. For providing the DC voltage, we will be calculating the resistance value, but here we are providing the AC supply, right? The alternating current we are supplying. So for that case, we need to calculate the reactance value. That is what impedance is. So for the calculation of reactance, your frequency, that is frequency